All right, eighth graders. So we're going to work on rate of change and slope today. We're just going to dive right on in. Maybe. There we go. So rate of change shows the relationship between two changing quantities. So the rate of change is the difference in y over the difference in x. And in upper level math, we call difference delta. So delta y over delta x. And so that's our rate of change. The difference in our dependent variable over the difference in our independent variable, however you want to think about it. All right, so finding rate of change from a table, what we need to do is first we need to make sure that it's a true rate of change that is the same for every set of points. But really from a table, if you know that it's a linear function, then it's going to be the same all the way through. So what I'm going to do is I'm going to take this would be x and this would be y. And I'm going to take 520. So I'm going to take this point here and this point here. And I know my ovals didn't go very well. So I'm going to take 520 minus 260 because that would be y minus y. So I'll get a difference in y's. And I'm going to put that over 2 minus 1. And kind of as a double check, I'm going to go for 780 minus 520 over 3 minus 2. All right, so up here, 520 minus 260 is going to give me 260. And 2 minus 1 is 1, and we should always reduce our fractions or simplify our fractions. So 260 divided by 1 is 260. And so this would be feet per minute. And then when we do 780 minus 520, again we get 260, and then 3 minus 2 is 1. So we end up with 260 feet per minute. If I wanted to, I could do 1040 minus 780 over 4 minus 3. I'm still going to get 260 when I do 1040 minus 780, and 4 minus 3 is 1. So we end up with 260 feet per minute. What this tells me when they all end up that way is that it is a true linear function, and that the rate of change is 260 feet for every 1 minute. Or as we say, instead of for every, per minute. And so that's the distance marched, 260 feet every minute marched. And like I said, if you know that it's a linear function, you just need 2 of those points and you're going to end up finding your rate of change. Now, rate of change is a constant. That's why I called it a linear function. All right, so rate of change is what we call slope, or slope is rate of change. Those words are interchangeable. And slope is the ratio of the vertical change to the horizontal change between 2 points. So, like we said before, delta y over delta x. Or, if we're going from a graph, we think of this as rise over run. So how much up or down over how many over. So when we're finding slope from a graph, I always start from the left point and I count to my right point. So here we went up 2 and over 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So we went we went up and over. So up 2 over 5. Slope is also called, I guess I didn't put this in here. We also refer to slope as the variable m when we work with slope. And then something else to keep in mind is that up and right are positive moves, and negative moves would be down and left. I don't know what I was trying to put with down. Now that's gone. So negative moves would be down and left. Okay, so we went up and right, so they're both positive. So my m is going to equal 2/5. Here I'm going down 2, so that's going to be a negative. And over 1, 2, 3, 4, 5, 6. And again, that was right. So m will equal, my rise was actually a fall of 2, so that's going to be down 2, and I still went right 6, so now I'm going to simplify, because we should always simplify our fractions, and negative positive will be a negative, and 2 goes into both, so we're left with 1/3. And so we've got a slope of 2/5 and a slope of 1/3. And that's where we'll finish this video. In the next video, we're going to talk about if we're not given a graph, but we're given 2 points, and then horizontal and vertical lines. I do want to point out, if you are not given 2 points on your graph, you find them by going where they cross at what I call crossroads, but you want that line going through the 4 corners. So like here, we know that it's crossing at -3, 2, and over here we know that this one's crossing at 3, 0. We want them happening at points, not these intermediary points here, because even though they are points on our graph, they don't help us find slope because we're having to guess what their position is, and that makes that harder. All right, so I'll see you in the next video.